Hi students, next we are going to discuss about that Poiseuille's equation. Poiseuille's equation. Poiseuille's he studied the flow of liquid in the capillary tube. Steady flow of liquid in the capillary tube. So consider this is the capillary tube. Capillary tube means that is the radius is very small. Okay, so the radius is very small of the tube. So maybe r is equal to 0.1 centimeter. So like this, or that means 1 millimeter. That is called as a capillary tube. So that tube, this is considered one capillary tube. So that liquid will be flowing very steady. So he derived the derivation volume of the liquid per second. He is derived the derivation volume of the liquid per second through the capillary tube. So is how much? That is he derived. Okay. So before we are going to derive the derivation, we have to following some condition. So what are the conditions mean? First, that flow, that liquid flowing is a streamline flow. The liquid flowing in the capillary tube must be in a streamline flow. And second one, the tube must be in horizontal. The tube must be in horizontal. And third point, so the tube layer, so this is the tube layer at the wall. Okay, so the tube layer at the wall, it must be at rest. The tube layer wall must be at rest. And fourth point, pressure is constant. Tube wall layer at rest. Pressure is constant for the whole tube. Okay. So if you take any one point, the pressure must be a constant. So this condition you must be followed. Okay. Then now we are going to derive the derivation for volume of the liquid flowing per second in a capillary tube. So volume of the liquid flowing per second, that is a volume by time, that is equal to, we can say that simply V. Okay, V is equal to volume of the liquid per flowing per second. It depends upon, what are the factors it depends upon? Mean first one, coefficient of viscosity. The coefficient of viscosity symbol is eta. Okay. So the volume of the liquid flowing per second is depends upon the first one, coefficient of viscosity, and second one, radius of the tube, and third one, pressure gradient. That means P by L. Pressure gradient means per unit length how much pressure is there. That is called as a pressure gradient. Okay. So P is equal to P by L. Already we discussed in fourth chapter. In fourth chapter, energy gradient, potential energy gradient. That means du by dx. Okay. So in unit length, how much potential energy is stored? That is called as a potential energy gradient. Here, pressure gradient means pressure per unit length. So volume of the liquid flowing per second is depends upon the coefficient of viscosity, radius of the tube, and pressure per pressure gradient. Okay. So this will be we have to derive by using dimensional formula. In first chapter we discussed no. Okay. So dimensional formula by using that. So first, the volume of the liquid column depends upon is directly proportional to eta power A. Okay, so there is the A is the variable quantity, coefficient of viscosity, and R is the radius of the tube, and power B is the variable, and the pressure gradient P by L, that is C. Okay, so these are all the variable. Now you can apply the dimension formula. So first you can equate this equation. So V is equal to K eta A R power B and P by L the whole power C. Here V. So what is the dimensional formula for volume flowing per second? That is V is equal to V by T. That's equal to volume. Dimensional formula is L cube by time is T. Okay. So that dimensional formula for volume of the liquid flowing per second is L power 3 and T power minus 1. And next coefficient of viscosity eta. The dimensional formula for coefficient of viscosity is m L power minus 1 and T power minus 1. And radius of the tube. Radius of the tube is L. And third one, pressure gradient P by L. The dimensional formula for pressure is m L power minus 1 and T power minus 2. That pressure is equal to, what is the formula? Force per area. So force unit dimension formula is m L T power minus 2 divided by area. L square L cancel. So you can get m L power minus 1 and T power minus 2 divided by L. So m L power minus 2 and T power minus 2. The dimensional formula for pressure gradient is m L power minus 2 and T power minus 2. Now, so these are all the dimensional formula. You can substitute this equation number 1. So first, volume of the liquid flowing per second is, the dimensional formula is L cube T power minus 1. L cube T power minus 1 is equal to K. K is a constant. Okay. So K and eta. K is the dimensionless constant. Okay. So eta is the dimensional formula is m L power minus 1 T power minus 1. M L power minus 1 T power minus 1 to whole power A. And next, eta, radius of the tube L, V. And pressure gradient is m L power minus 2 T power minus 2. Okay. Now I can rub this equation. So I can write this equation. L cube T power minus 1 is equal to K m. K on the dimensionless constant, so just you can neglect that. M L power minus 1 T power minus 1 the whole power A, and L power B m L power minus 2 and T power minus 2 the whole power C. So this will be, we can modify it as m power 0, m power A power 0 value 1. So for a derivation, I can put that value m power 0, L cube and T power minus 1 is equal to, here m power A, L power minus A and T power minus A, L power B and m power C, L power minus 2C and T power minus 2C. Okay. Then next, the base will be equal means the powers should be adding. Okay. So what is the formula? A power m into A power n is equal to A power m plus n. So this formula you can substitute that. Is equal to m power A, here plus A is there, and here plus C. Then next L power, here minus A, here plus B, and here minus 2C. Then next T power, here minus A and here minus 2C. Okay, minus A and minus 2C. In left hand side, m power 0, L cube and T power minus 1. In both sides, base will be equal means the powers also equal. So A plus C is equal to 0. Then next minus A plus B plus 2C minus A plus B minus 2C is equal to 3. Then minus A minus 2Z minus A minus 2C is equal to minus 1. So this is the equation number 1, and this is the equation number 2, and this is the equation number 3. Now I am going to adding first and third equation. Adding first and third. So A here plus A and minus A both are cancelled. I can write A plus C is equal to 0. Then minus A minus 2Z is equal to minus 1. Now you can adding this equation. This cancel and minus C is equal to minus 1. So we can get C is equal to plus 1. Here minus C is equal to minus 1. Minus minus cancel. We can get C is equal to plus 1. Then next you can substitute that value in equation number 1. A C equal to 1. So A plus 1 equal to 0. Then A is equal to minus 1. Okay. So both the values you can substitute in the equation number 2. C value plus 1 and A value minus 1. So you can substitute means minus of minus 1, that is plus 1, plus B minus 2C. C value 1. So minus 2 is equal to 3. So 1 minus 2 minus 1. So B minus 1 is equal to 3. Then B is equal to 4. Okay. So C value is 1 and A value is minus 1 and B value is 4. Okay. So this value, so you can substitute that equation, this 1 or A. You can take that A. You can this value you can substitute that equation A. Okay. So V is equal to K of eta. A value is minus 1 and R B power B value 4 and P by L the whole power C. C value is plus 1. Then beta is equal to K R power 4 P divided by eta L. Okay, so K is a constant. That K value you can substitute by 8. We can get B is equal to 5 by 8 R power 4 P divided by eta L. So this is the volume of the liquid flowing per second. Formula is pi P R power 4 by 8 eta L. Okay, do you understand, ma? Okay, that's all. Okay, thank you.